Hello everyone. So in our previous video, we discussed about asymptotic notations, and we also discussed that how asymptotic notations help us in determining the running time of an algorithm in terms of its input size. And we also discussed that asymptotic notations help us in determining the best case, average case, and the worst case. And we also saw an example of a car, that how the performance of car in 1 liter of petrol differs in different situations. So similar analogy is being performed on the algorithms where we determine the best case, average case, and the worst case. So there are types of asymptotic notations which determine these three cases. So here you can see that there are three notations for performing the running time analysis of an algorithm. The first notation is the omega notation, which is being denoted by omega symbol. The second is the big O notation, and the third one is the theta notation. So let's discuss about the omega notation first. So if we see the definition of omega notation, so this notation basically expresses the lower bound of an algorithm's running time. Now what do we mean by the lower bound of an algorithm's running time? So basically lower bound means that for any given input size, this notation determines the best amount of time an algorithm can take to complete. So by best amount of time we mean the lower time. So therefore we denote it by lower bound, and this determines the best case of an algorithm, because omega notation provides us the best amount of time an algorithm can take to complete. So as we already discussed that this is the best case analysis of an algorithm. So what do we mean by best case? Let's say for example, if we have written certain algorithm and if we say that algorithm takes 100 seconds as the best amount of time. So what do we mean by that is that 100 seconds will be the lower bound of that algorithm, and the algorithm can take more than 100 seconds to complete, but it will not take less than 100 seconds to complete. So the best case analysis takes the lower time and provides us with the information that a particular algorithm will take minimum, let's say 100 seconds, but will not take less than 100 seconds. It can take more than 100 seconds, but as the lower bound is 100 seconds, it will be the best case for that algorithm. So this notation is very least used because we are not interested in finding the best amount of time algorithm can take. But this notation basically provides an information that what's the minimum resources we need to run this algorithm. The other notation is big O notation. So this notation expresses the upper bound of an algorithm's running time. Now what do we mean by upper bound? Upper bound means that for any given input size into an algorithm, this notation determines the longest amount of time the algorithm may take to complete. Now what do we actually mean by the longest amount of time? Let's say for example, that if we say that certain algorithm takes 100 seconds as the longest amount of time, so 100 seconds will be the upper bound of that algorithm in big O notation. The algorithm may take less than 100 seconds, but it will not take more than 100 seconds. So this is very opposite of the omega notation. So when we say that 100 seconds is the longest amount of time that algorithm may take to complete, then that would be the upper bound. The algorithm may take 90 seconds, 80 seconds, but it won't take more than 100 seconds. So this notation is mostly used because we are very much interested in finding the maximum amount of time the algorithm may take to complete, so that we can optimize that algorithm to whichever time we want. So here the big O notation basically provides us the worst case analysis of an algorithm. By worst case we mean that it determines the longest amount of time the algorithm may take to complete. Moving ahead, the third notation is the theta notation. Now this notation basically expresses both upper bound and the lower bound of an algorithm's running time. So what do we mean by both upper bound and lower bound? It means that for any given input size to an algorithm, this determines the average amount of time. So basically the average case analysis is being determined by the theta notation. So for example, if we say that certain algorithm takes 100 seconds for the first run, 120 seconds for the second run, and 110 seconds for the third run, and so on. So theta notation gives an average of running time of that algorithm. So it basically determines the average of the upper bound and the lower bound of an algorithm's running time. So this notation is also very leastly used because there are very rare use cases where we actually determine the average time taken by algorithm to complete. So in this video we discussed about the three asymptotic notations which are being used to determine the running time of an algorithm, and these three notation also determines the best case, the average case, and the worst case analysis of an algorithm. I hope you have liked this video. Thanks, have a nice day.